Hi, now in this lecture I am going to explain about which is minimization of Boolean functions. Yeah, I am Dr. Ravikumar, Associate Professor, Department of ECE, Institute of Aeronautical Engineering. In this module we can have two parts. First part is Karnaugh map methods and second part is combination of logic circuits. In this first part, how to use this Karnaugh map method to minimize the Boolean function or realization of the Boolean function up to 5 variables and including with don't cares and tabulation method. And then we move to designing of combination circuits, for example adder, subtractor, comparator, multiplier, multiplexers, demultiplexers, encoders, decoders and code converters, and then finally hazards and hazard free relations. As a part of this fourth module, first part Karnaugh map, before going to start this lecture, in the just we recollect the previous lecture that the realization using basic gates and universal gates. If we have a Boolean function which is in either form of sum of product or product of sum, in both cases when we take the Boolean function and implement it in AOI diagram or inverter form, otherwise we can have to design or implement a realization of these Boolean functions using nan and nor. So in the previous lecture, just if I am taking simple example of Boolean function and design with this and inverter gates, and then we move to multi-level gates using nan and nor gates. The main purpose of this nan and nor gates they are called it as universal gates because we can design any basic gates, and also for the different kinds of Boolean functions, non-standard forms or standard forms, if they are in multi-level we can convert into nan and nor gates. The main purpose is to convert nan and nor gates are, if we convert any Boolean function into NAND gate or NOR gates, then at the time of implementation we can easily pick up those NAND ICs and OR ICs, the uniformity, so similarity or uniform, all gates replaced with a simple uniform gate like NAND and NOR gate, so that we can easily pick up the ICs and we can connecting and to achieve particular realization. In this, what happened when we increasing the Boolean function or number of variables? The Boolean function is a 4 variables, 5 variables, 6 variable. So when the Boolean function, as we increasing the variables, it is somewhat difficult applying the Boolean theorems, Boolean algebra or basic theorems, axioms. So basically the Boolean function may be simplified by algebraic theorems. However, this procedure is somewhat difficult and this procedure of minimization is somewhat awkward, as the Boolean function is made with a number of literals, a number of minterms. So in order to avoid those confusions and awkwardness, we can go with the Karnaugh map. The scientist Karnaugh creating this map for minimizing the Boolean function. It is simplest and a straightforward procedure. We can see now why it is and how it is straightforward and very easy to implement a complex function. When we see this Karnaugh map, the Karnaugh map is a diagram made up of squares or square boxes. Each square box represents one minter. Since Boolean function is made up of minterms, those minterms can be represented in the Karnaugh map as it is included in the Boolean function, represented by a square which is included in the Karnaugh map. Similarly, we can also represent this Boolean function in PYS form. We can also Karnaugh map of squares represented in for PYS also. Let us now discussing about what is this Karnaugh map and how these squares represented, make them to a big map, and how to represent or how to place those minterms of Boolean function in the Karnaugh map square boxes. Let us first, we can take the two variable function has 4 possible minterms. We can rearrange these minterms into Karnaugh map. So the two variable function, like if you see this any two variable function, variables are x and y. If any two variables, how many possibilities in these two variables are nothing but 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So those possibilities can be represented as minterms, and these minterms are represented in the Karnaugh box or Karnaugh map. By recognizing various patterns, the user can derive alternative algebraic expressions for the same function, from which he can select the simplest one. We shall assume that the simplest algebraic expression is anyone in the sum of products or product of sums that has minimum number of literals. So as we go through the Karnaugh map presentation, so user can select a easiest way to minimize the minimum number of literals. Let us see what is what is the Karnaugh map and how to represent these minterms in the Karnaugh map. This two variable map, like if it is a two variable, are literals x and y. When there are two variables, 4 possibilities we have: 0, 0, 0, 1, 1, 0, 1, 1. The representation of minterms for this two variable function, all possibilities of minterms can be represented with the literal x corresponding 0 represented as complemented, and y, literal y, its corresponding 0 means it's a complemented y. X bar, y bar is the product of two variables. We can call it as minterm. And 0, 1 can be represented in SOP form. The product x bar y is a minterm, another minterm. So that we can have 4 minterms: x bar y bar, x bar y, x y bar, x y, which corresponding the input combinations of 0, 0, 0, 1, 1, 0, 1, 1. How to represent these 4 minterms of two variable function in K-map? So basically a K-map is made up of square boxes. A two variable K-map can be made with 4 square boxes. Each square box is represented with its minterm. Here, if it is this first square box represented as minterm 1, second box minterm 2, third minterm 3, fourth minterm 4. How can we place those minterms in a particular square boxes? If you see, take in vertical direction and horizontal direction, take these variables, input variables. If I am taking input variable x in this vertical direction, and take the input y in the horizontal direction, and also this variable, the possibilities of one single variable of Boolean values are 0 or 1. The possibility 0 in this first row, and the possibilities of x is equal to 1 in the second row. And another possibilities of variable y is one possibility is 1, 0, and another one 1. So when we take the sequence and follow this reference f of x, y, x comma y is the function. So we can take the starting variable is x and then y. We can take this x is equal to 0 and y is equal to 0. The first row of the square box in horizontal and first column of the square box in this y can be represented with 0. So first row of the variable x can be represented as x bar. Here it is x bar. You can take it as x bar. Whenever it is taken considered as x bar and x, this can be represented with y bar y. So in order to represent first min term x bar y bar are 0 0, take the first row of the x direction and the first column in the y direction. X 0, y 0, this can be represented with 0 0, and in decimal number of this 0 is 0. So we can represent a min term mj, m suffix j, where j is nothing but decimal number equivalent of this combination. So we can represent it with a small m suffix 0. And this can be represented with the horizontal first x bar term 0 and y column 1, 0 1. 0 1 can be represented with a min term can be represented with m1. And second row in the x axis or x column 1, and first column in the y direction 0. 1 0 can be represented in the min terms is m2, and 1 1 can be represented with in the min term is m3. So those four min terms m0, m1, m2, m3 can be placed in a boxes according to the reference x and y, where x is equal to 0, y is equal to 0, m0, x is equal to 0, y is equal to 1, m1, x is equal to 1, y is equal to 0, m2, x is equal to 1, y is equal to 1, m3. If you know the position or place of those min terms like m0, m1, m2, m3, then the given Boolean function, two variable Boolean function, whatever the min terms which exist in the Boolean function can be enclosed by those boxes, can be included in those boxes, whatever the min terms existed in the Boolean function. That corresponding numbers are placed one in the square box, and the remaining terms, whatever the terms not existed in the Boolean function, can be represented with the logic 0. Then we can perform the Karnaugh map method minimization to get the minimum number of literals in the Boolean function. So as we know the place in the Boolean function x bar y bar, x bar y, x y bar, x y, then whenever we can take those min terms, then we can perform the minimization. Here, in order to minimization, we can take some simple straightforward method. We will see as we go along with this three variable function. So this is the three variable function. In this three variable function, we can create the Karnaugh map with the three variables ABC or XYZ. Let us take ABC. So when we have a three different three variables, we will have maximum of 2 power 3 possibilities and 2 power 3 unique min terms. So those min terms are 0 0 0 2, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So the corresponding min terms are A bar, B bar, C bar, which is represented with M0, and A bar, B bar, C, which is represented with M1, M2, M3, M4, M5, M6, M7, where M7 nothing but A, B, C. In this minterm representation for the 3 variable, the 0 can be represented with unprime, and 1 can be represented with 1 can be represented with unprime, and 0 can be represented with prime, and 0 can be represented with the complement variable, and 1 can be represented as uncomplemented form. So 7, 1, 1, 1 nothing but A, B, C, the product of A, B, C. Now this can be represented in a 3 variable function. So remember, a function is followed a variable A, B, C is the reference order. So we can count those binary numbers or minterm representation start from A and then B and C. So that is the reference order. So we can create the K-map square square boxes for this 3 variable function. 3 variable means we can have 8 boxes. 8 boxes must be taken it as either 2 rows and 4 columns, and or 4 rows and 2 columns. So this is the 4 rows and 2 column way, and this is the 2 rows and 4 column way. In the 2 rows and 4 column representation, take the A in a row side and BC in column side. In this square box, in this K-map Karnaugh box can be represented with 3 variable function in 8 square boxes. 8 square boxes can be divided in such a way that we can take 2 rows, 4 columns, or 4 rows, 2 columns. Let us consider this 2 rows and 4 columns. In this 2 rows and 4 columns, we can take the row side can be 1 variable A, and column side we can take 2 variables BC. So when we can represent it among those 8 possibilities of minterms ABC, let us take considered as 0. 0, 0, 0 means A bar, B bar, C bar. So that can be called as first row of A 0 and first column of BC 0, 0. So that we can create 0, 0, 0. That 000 is its equivalent decimal number is 0, and its corresponding minterm represented with small m suffix 0. So that's why we can take that small m suffix 0. And then 0, 0, 1. 0, 0, 1 means M1. We can represent that one is M1. And 0, 1, 1. 0, 1, 1. 0, 1, 1 which is corresponding minterm is M3. And 0, 1, 0 we can corresponding minterm is M2. As we see this sequence in the column, when we encounter this sequence of B and C terms, we cannot take the as Boolean sequence 0, 0, 0, 1, 1, 0, 1, 1. But we can see here the sequence of this BC. Here it is 0, 0, 0, 1, 1, 1, 1, 0. This sequence is called reflected codes, or this sequence is called gray code representation in the K-map. That is what K-map identified the sequence representation in the K-map. So what is the main purpose that Karnaugh take those gray code representation in BC means, as we studied in the basic Boolean theorems, minimization of Boolean theorems, if we take any two expressions, let us take x bar, y bar is the one minterm, plus x bar, y is the another minterm. It is a Boolean function. So according to basic theorems, basic axioms or theorems, how to minimize this Boolean function, take the common term x bar, factor out, and then we can take this y bar plus y. So y bar y is nothing but 1. We can get the minimized function is x bar. This similar idea when we see in this Karnaugh map sequence, whenever any one minterm with the neighboring minterm or adjoining minterm, one variable change or one bit change. So here it is 0 0 and 0 1, only one bit change, second bit, and 0 1 to 1 1 we can have one bit change, that is first bit, and 1 1 to 1 0 we can have one bit change. This kind of one bit change we can arrange in the K map so that we can have a possibility to minimize the Boolean function, just as this one. This is a 0 0, this is 0 1. 0 0 0 1 is the two adjacent minterms. When we have two adjacent minterms, definitely one variable is its in its two ways, normal form and complemented form, so that it can be minimized by take the common variables separate and then we can minimize the two minterms into one single letter, in this case one single literal. So, and also we know that the procedure how to convert this binary to gray code, we know that. So if we want to convert this binary to gray, we can take this one and the XOR operation of this one, this MS bit to the next bit. If XOR operation, sorry, so this one is, if your MS bit is take as it is, the XOR operation of this MS bit with the next neighboring bit is, we can get 0 1 is nothing but 1, and then we can have next sequence is 0 1. What is its corresponding gray code is MS bit take as it is 1, and what is the XOR operation of 1 and 1 is 1 0. Zero zero 0 1 1 0 1 1 0 0 binary to gray conversion 0, and what is the XOR operation with the neighboring is 0, and MS bit as the 0. What is its XOR operation is 0 1, XOR operation is 0 1 1, and take the MS bit as it is 1. Its XOR operation is 1 with 0 1 1 1, and take the MS bit as it is, and its XOR operation with the neighboring bit is 0. So that the sequence, once converting the binary sequence 0 0 0 1 1 0 1 1, its corresponding gray code is this 0 0 0 1 1 1 1 0. That's why here we are taking 0 0 0 1 1 1 1 0. Once we observe this sequence to this sequence, this sequence to this sequence, this sequence to this sequence, only one bit change. Whenever any minterm, its neighboring minterm having only one bit change, then there will be a possibility to minimize Boolean function, one literal possibility minimization. So in that way we can have this first row, second row of the literal A, variable A, and first column of the BC. 1 0 0 means which represents 4, minterm M4, and then 1 0 1 nothing but minterm M5, 1 1 1 nothing but M7, 1 1 0 nothing but M6. This 0 1 3 2 4 5 7 6. So very simple to remember, it is 0 1, then only one bit interchange, in the sequence 0, 1, 2, 3. So we can have 0, 1, 3, 2. And 4, 5. Instead of 6, 7, we can have 7, 6. 4, 5, 7, 6. That is the order in the minterm representation in the square box of Karnaugh map. So this can also be represented with the minterm representation like M naught nothing but A bar, B bar, C bar, where A bar nothing but A0, B0, C0 nothing but B bar, C bar. Likewise, we can have 0, 1, 3, 2, 4, 5, 7, 6 minterm square boxes can be placed its corresponding 8 possibilities of 3 variable minterms. Once we have know this, the idea to place those minterms in the Karnaugh map, whatever the Boolean function, we can take those Boolean function and place its corresponding minterms. Values of those square box is 1, remaining value is 0, and then we can apply the Karnaugh map method to minimize the Boolean function. Here, one more important note to be here to remember while performing the 3 variable Karnaugh map. For example, in the square box Karnaugh map, it is a 3 variable x, y, z. In horizontal, I am taking x value. In x, we can divide into 2 rows like x is equal to 0, x is equal to 1, and yz can be divided into 4 boxes. So yz 0, 0, 0, 1, 1, 1, 1, 0. Whenever we have a Boolean function, only one minterm. Here it is one minterm. Whenever it is one minterm, there is no possibility to minimize. Take that one minterm, and one square box can be considered for that Boolean function. One square box represents one minterm, giving a term of 3 literals. It is a 3 variable function. We can have a x in x direction second row, and third column x, y, z is the function. There will be no minimization. Whenever 3 variable function, we can have only one circle, one square box, no minimization. We will get 3 literals only. Suppose in this same example, if I am taking 2 adjacent squares, those minterms are existed in the Boolean function. When 2 adjacent squares represent a term of 2 literals, for example, there will be a minterm exists in the Boolean function. We can consider as 1 in the box. Another Boolean function we can consider as 1 in the box. So whenever these two adjacents in the square boxes, we will have minimized those 3 variables into 2 variables. And 4 adjacent squares are represent a term of 1 literal. We can minimize these 3 variables into a 4 variable adjacents of 1s. We can minimize into 1 literal. And 8 adjacent squares encompass the entire map and produce a function that is always equal to 1. So in this case, it is very easy to remember the shape of those adjacent ones, either 1 1 in the square box, entire out of 8 boxes, only 1 1, or 2 1s, or 4 1s, or 8 1s. How to remember? By seeing these shapes of those square boxes. If you consider a pair, 2 ones in the square boxes, 2 adjacent ones, we can call it as pair. 1 literal, pair, 4 literals, like 4 minterms adjacented together, we can call it as quad. And 8 rectangular, we can call it as a rectangular in the 3 variable function. Rectangular. This one, no way we can take that circle and it will come 3 literals. But in a pair, so that pair may be, it will be in horizontal, one beside another one, or it will be one beside another one in vertical mode. So in vertical direction, we take these two boxes, is call it as pair in this fashion, and we can also take this pair can be this fashion. So these two one adjacent ones are called pair. This kind of shape, whenever it comes, that those two adjacent squares represent a term of two literals in the three variable function. Similarly, is there any four ones here? Here you can come with the four ones. So that four ones look like a square box among 8 square boxes in the Karnaugh map in the three variable. We can have square box, four ones. This is one way to look at in the 8 boxes. And another way is when we remove this one. And another way is we can have this way, four ones also there. So this can be represented with this rectangle, four ones like squared. We can also represent it with this one. This is also one quad in the 3 variable function. In this, one x variable is in two row in horizontal and yz in vertical direction. This Boolean, this K map, we can have quad in a square shape and in rectangular shape with the four ones, with adjacent four ones. Suppose that a K map, 3 variable K map having all ones in the 8 boxes. When it have all ones, these 8 ones can be represented with a rectangular shape. Always rectangular, it's not a square, always rectangular. So all ones are there. When all ones are there, so every square box, including all square box, are encompassed with this minterms, all minterms, so that everyone is neighboring with the every minterm, it's neighboring with a neighboring minterm, so that among those two there will be possible to minimize one literal. So likewise, we can all minterms having a interrelated, there will be possible to minimize everything, all variables cancel together, you will get logic 1 in the output. So we can have all number of ones in the 8 square boxes, then the answer should be the one minimum. The answer should always have logic 1. There will be no literals in the expression. So this is 3 variable K-map. How to remember, how to identify by placing the minterms value in the K-map. After placing the minterms in the K-map, then how can we identify? By pair, by quad, by rectangle. In this case, we can see simple one example. This example will help us to understand how to place those minterms in the K-map and how to minimize by following those shapes of this like pair, quad and rectangle. So in this case, the Boolean function can be represented in many ways. Like one way is in mention minterms in variables, either form of complementary or uncomplemented form, or by taking sum of all minterms like m2 plus m3 plus m4 plus m5, or otherwise the easiest way is to represent with a sigma of 2 comma 3 comma 4 comma 5, which represents minterm 2, minterm 3, minterm 4, minterm 5 in the Boolean function. The SOP form of m2 plus m3 plus m4 plus m5. So how to take this 3 variable function and place in the K-map? First, it is a 3 variable K-map. We can have two possibilities. One way is 2 rows 4 columns, or 4 columns 4 rows to 2 columns. I am interested to take 2 rows and 4 columns. So I am taking 2 rows and 4 columns. 2 rows and 4 columns. I can draw these 2 rows and 4 columns. I am considering these 2 rows can for one variable like x and 4 columns assigned by 2 variables y, z. The representation of Boolean value for that first row is 0 and complemented value of x and uncomplemented value of x 1. And yz can be represented in a gray code order 0 0 0 1 and 1 1 1 0. We know that what is 0 0 y bar z bar, what is 0 1 y bar z, 1 1 yz, 1 0 y z bar. We know also that the number in each square box, it can be represented with 0 1 3 2. We need to be by hearted those decimal number place of these square boxes 0 1 3 2 4 5 7 6. Now what are the numbers, what are the minterms that Boolean function has? 2 3 4 5. Corresponding square box of 2 place 1 and third 3 is the one minterm which is exists in the Boolean function. We can place 1 and 4 we can place 1 and 5 we can place 1. Now after placing this Boolean, after placing these minterms, its corresponding logic 1 in the corresponding square box, the immediate step is try with the highest possibilities. In order to get minimized literals, take the highest possibilities of square of ones in the number of ones in the K map. Is there any all ones in the entire all boxes? Like 8 ones are there, check it once. So there will be no 8 ones in the problem, given problem. So we can avoid, we can neglect the 8 ones. 8 ones means we can have rectangular shape. So there is no possibility to have 8 ones in the K map. And the next one is first priority this one. Second priority is quad. Second priority is quad. Is there any 4 ones neighbor? Like 4 ones are connected one to another, or 4 ones are grouped in one place. So here it is 1, here it is 1. There is no 4 horizontally or square wise. We can have 2 shapes. One is square, another one is horizontal. 4 ones. So there is no quad. So only possibility is pair. So we can go with the pair, third option, third priority. So what are those pairs? So to cover all the ones with the boxes, first priority to choose these 4 ones. How to cover these 4 ones? By applying pair. So there is a one pair, like we can collecting this pair like this, and there are 2 ones are left. How to cover those remaining 2 ones? By connecting pair. So again we can have this pair. So once connecting with the help of pair, because 8 is not possible, quad is not possible, then we can go with the pair. So finally we can cover all ones. Once we can cover all ones, how to take the minimized Boolean function or minimized expression? By combining those ones in pair. So take the first pair. This one is the first pair, for example. How to derive the expression? How to realize that expression? The derive the expression in horizontal second row is 1, nothing but x. You can call it as x. And if you take the horizontal vertical direction, in this vertical direction there are two terms 0 0 0 1, nothing but y bar z bar and y bar z. By taking these two terms, is there any common term? Common term 0 is the common, y is the common, y bar is the common in two cases. So take that common term and eliminate the complementary term, because we can take the common term separate and z bar plus z can be treated as 1. So that's why we can take common term 0 0 0 1. The first logic value is 0, nothing but y bar. Y bar is the common term. So we can take that y bar x in. There is no chance to take the common term in the x horizontal direction. So consider that 1 as x multiplied with and product term with common term in the y direction, vertical direction, like y bar x y bar, like in this direction. So we can take the in this direction 1, nothing but x as it is, and in this direction we can take the common term. So this common term x y bar. Then second, how to get the second pair? We can separate it with the R operator because it is in SOP form, and find out what is the minimized function by considering this pair. So this is in first row. First row means x bar, and what is the common term in in vertical direction of these two numbers 1 1 and 1 0? 1 is the common, nothing but y. So x bar y, such that according to rules also in a 3 variable function, for pair 2 variables comes, 2 literals comes. For a single one square 3 literals comes, and quad 1 literal comes. 8 ones, logic 1 is the answer. So according to that also 2 pairs are there, 2 literals, 2 literal min terms are 2 terms are there. So x y bar y for the minimized Boolean function for function given sigma 2 comma 3 comma 4 comma 5. This is the another example. Given the Boolean function f is equal to a bar c plus a bar b plus a b bar c plus bc. This is it is not in a standard form. It is simple SOP form, but it is not canonical form. It is a standard form. So in order to get that number minimized, like a minterm number, we can have a canonical form representation. Otherwise, we can also directly place those canonical form minterms in the K-map. One way is replace this expression this expression can be represented in canonical form, like which term is missing in the first term is b, so we can take the AC b plus b bar, and what are the term missing in the second a bar b, c term is missing c plus c bar, and the third term is having all literals either in form complementary or uncomplementary, so no need to take. So and the final term is missing a, so we can take a plus a bar. So once expanding this one, a bar bc, a bar b bar c, a bar bc, a bar bc bar plus a b bar c, a bc, a bar bc. Is there any repeated terms? We can check it. A bar BC, A bar BC, we can cancel one term. And then we can see here A bar BC, A bar B bar C, A bar BC nothing but A bar nothing but logic 0, BC nothing but logic 1 1. So 0 1 1, 0 0 1 plus A bar B C bar 1 0 1 0 1 0, A B bar C 1 0 1 101 111 0 1 0 1 A bar B C. Again you can have the second term, we remove that one. So that what is the corresponding minterms? 0 1 nothing but M3, M1, M2, M5, M7. So we can represent it with the sigma of 1, 2, 3, 5, 7. So if you take the K map for this Boolean function, so I am preferring 2 rows and 4 columns K map. I am taking the A in a horizontal, BC in vertical, 0 1 3 2 square boxes 4 5 7 6. So we can have 1 2 3 5 7 are the minterms. One, 2, 3, 5, 7. So in this case, after placing the ones, so next we can consider the number of ones shape. First priority is number of ones are 8s are there, 8 ones are there. So there will be no all ones in the entire box. So the next to second priority is 4 ones are there. So quad, we can check with the quad. Quad, it has 2 ways, square box and 4 horizontal ones. So there will be one square quad. So we can prefer that quad. And it covers 4 ones. So remaining only one is left. In order to cover this one, if it is 8 ones are there, no. If it is 4 ones are there to cover this one, that is the best way to minimize. But there will be no 4 ones to cover to this one. So there is only possibility is pair. We can take pair. So one quad and one pair to minimize the Boolean function. What is the Boolean expression to get that square box, quad and a pair? Take the square box. So in this square box, how to get this one means, we know that A is 0 and 1 in the horizontal, and BC 0 0, 0 1, 1 1, 1 0. In order to get the square box expression, take it covers 2 horizontal lines. Okay, 0 line and 1 line. So 0 and 1 cancel together. So no A term comes. And come to vertical direction. In this vertical direction, 0 1 and 1 1 is the 2 terms in the covers the square box. What is the common term in 0 1 and 1 1 is second one. Second one is the common. 1 means C here. So we can have only C comes. C plus. I will repeat once again. This square box, in order to get the Boolean function for this square box, take the horizontal direction. It covers 2 horizontal lines, 2 horizontal square boxes. One is A0 and one is A1. So when we take the A0 and 1, this 0 and 1 cancel together. And consider the vertical direction 2 boxes, this one and this one. What is the common term in the 2 boxes? 1 is the common, 0 1 1 1, 1 is the common. 1 means C here. So B bar and B cancel together. So only we can have C. And then pair. It is covers only one horizontal line, 0. Consider that 0 like A bar. What is the common term in these two boxes? 1 1 and 1 0. This one and this one. What is the common term for 1 1 and 1 0? Here it is 1 is the common term. 1 means B here. A bar B. So the Boolean function, minimized Boolean function is C plus A bar BC is the minimized Boolean function. First case, this is a quad, so we can have only one literal minimize. Okay, we can have minimized literal is 1, final value is 1. And next it is a pair, so in the 3 variable K map, for pair we can have 2 variable, 2 literals. So C plus A bar B is the minimized Boolean function. Likewise, we can have performing the K-map, Karnaugh map method to minimize the Boolean function. Here it is important thing is remembering the square values, square box number, the order of the square box, and then placing the minterms, its corresponding square box value is 1 whenever that corresponding minterm will exist in the Boolean function. After placing the square boxes filled with 1, then identify the highest priority of all ones in the K-map boxes. Our next highest priority is, if it is 3 variable, quad and then pair, and then no possibility pair, then we can go with a single one. So we can write down its corresponding minimized Boolean function. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.